Good afternoon, everyone. My name is Matthew, and I'm part of the Functional Materials Group in RMIT University, and I will be presenting about my research project on the fabrication of large area field emitter arrays using both the combination of photolithography and EBL. So the outlines will be kind of like a general introduction of what field emission is, and we'll be going through the objectives, what the structures would look like, a simple fabrication flow, some of our current progress, and a quick acknowledgement. Yep, so field emission is basically when you are passing a high electric field through a really nanoscale sharp field emitter tips. You are basically lowering the potential barrier, and as you can see on the energy band diagram on the left there, and it would cause the electrons to tunnel through the surface of the conductor and will be emitted. And the idea is to basically create an electron source for the use in microwave devices, basically. And you can see on the right there is basically would be the circuit diagram that you would basically pass an electric field, and that the electrons would tunnel through the channel gap that would be existing right over here. So the objectives of this experiment is basically to create a fabrication method to realize up to 1 million of lateral nanoscale field emitter tips with a critical dimension of around 35 nanometers over a 1 centimeter squared area. And we will be also performing device characterization to basically determine the feasibility and performance for the use as in high power electron sources. So on the left here, you can see these are some of the fabricated samples that we have. And basically what we do is we'll make an array of these devices and then put them in like an electron hot funnel that will be fabricated by our collaborators, and then use that as an electron source. So going through some of the device structures that we are currently having. So it is a 1.5 centimeters, so we make it a bit larger for us to easier to work with. And we have like arrays line across here for individual testing. And so, yeah, so we'll be using a combination of photolithography to basically create the contact pads as well as the connections right here. And the red layer, so we have the using EBL basically to create all these nano electrodes. So some of the test samples that we are doing at the moment, so we are testing out different gap sizes from all the way from 35 nanometers all the way to 125. We are also testing a quick density test on to see how much tips we can cram in a certain area, as well as varying the geometry as well. Next would be a simple fabrication flow. So for the lithography, I believe most of everyone here would be pretty familiar. So you just spin coat, you expose it, and then you develop the resist, and you would perform an E-beam deposition. And the target layer that we are aiming to is have 200 nanometers of gold. So in the future, we will be experimenting definitely with a lot more different metals as well. So EBL, so we are currently using the EBL system in MNRF. It's the Voyager Wave system. So we'll be doing the same thing with the photolithography, where you spin coat the EBL resist and you perform writing, and then you would do resist development and deposition of metal as well. We are aiming to have like 40 nanometers of gold, and as well we can also vary the type of metal that we'll be using in our experiments. And these are some of our current progress that we have. So using different types of resist. So the top here, you can see that we are using A2 resist, around 80 nanometers of thickness. As we can see here, you there is a really clear outline, the shape as in the design here. So the design here has a tip apex radius of around 5 nanometers. So you can see that it comes out really well with a really nice gap size. And for A4, so you can also achieve similar gap sizes, but unfortunately, due to the higher amount of dosage needed to expose the resist, you get a more rounded shape on the end there. So that's not as ideal. And we also experimented like with different geometries. So with a slightly rounded edges using A4, we were able to achieve the perfect shape, basically as designed. Yep, so I think that's it from me today. I would like to just acknowledge my supervisor and as well as the MLS staff and RMIT microscopy staff. Yep. Any questions so far?